Hi guys, I hope you are doing fine. Then we're still talking about digital logic gates. On my last video, I made an OR gate fundamental rules, whereby I draw a symbol of an OR gate, and I also wrote a truth table for an OR gate, and I draw also a circuitry example that could illustrate or represent a logic, an OR gate logic. Okay, so today we'll be talking about an AND gate. So number 2 will be AND gate, right? So basically an AND gate is an opposite of an OR gate. Let's first draw a symbol of an AND gate. This is an AND gate, right? Have an input A and B. So on the basic principle of an OR gate was that input A plus input B will give you an output, right? But on the AND gate, it's not A plus. It's more like input A, right, multiply by input, let's say multiply by input B, it will give you output. So this means that both inputs depends on each other, right? So if it has to be true, if the output has to be true, both inputs has to be 1, right? So if you have one input as 0, then we're going to have an output of 0. So there can only be one true output. So if we draw a truth table, right? Truth table of this logic gate. So obviously we'll have A, B inputs, you know. Okay, let's write it separately there. So output, let's say here it's A, let's say here it's B, right? So we can input different inputs, right? Like 0, 0, so that will be 0 times 0, that will be 0, right? And I will output a 0 value. If 0 times 0, there will be nothing on the output. So if it's A is 1, B is 0, we know 1 times 0 will be 0, right? If A is 0 and B is 1, the output will be 0. So when it's 1, 1, so it will be 1 times 1, the output will be 1. So it can only be true when both A and B are 1 on the input, right? If now we can say, let's draw a circuitry representation of what we are talking about. So on the AND gate, on the OR gate, we saw that there were 2 parallel switches, right? So that means if one is true, the other one doesn't need to be true for the output to be true, right? So on this case of an AND gate, it's an opposite of an OR gate. So we will have 2 series switches, right? So if we have a circuit, like let's say we have a battery here, right? We have the first switch, then we have a second switch, then we have an LED here, a bulb, right? And this switch will be switch A, and this switch will be switch B, right? So it talks to us that both of these switches are in series, right? If switch A is 1, right? Switch B, if switch A is 1, that means switch A is closed. Switch B is open. Then the current won't be able to flow to the bulb, right? from the bit, the current won't be able to flow. Same applies when the switch A is open and switch B is closed. Current won't be able to go across the bulb. So this means it can only go, the current can only go across the bulb when both switches are closed, right? When both switches are true. So the current can only then go across the bulb, and then our bulb will glow. So this is how an AND gate on a logical digital systems operates. So for this concept, it's just a total opposite of an OR gate. So obviously in different applications, you can either use an AND gate or you can either use an OR gate. So thank you guys for listening to me. Hopefully you guys will subscribe and like the video at least. Thank you.